Hello guys, this is Rakesh from Bodhee Prep, and in this video we'll be continuing what we have learned in the previous video of quadratic equation. This will be the second video on quadratic equation. I hope you have gone through the previous video. If not, accidentally you have come to this particular video, then I'll highly suggest that you just stop watching this video, go and watch the first video because this will be the continuation of the first video, right? First video on quadratic equation. Okay, uh, just a second. Okay, so let's continue. So in the previous video of quadratic equation, we got a formula to find the roots of the quadratic equation, right? For the quadratic equation ax square plus bx plus c equal to 0, the formula is that the value of x would be minus b plus minus under root of b square minus 4ac whole divided by 2a, right? Now in this formula, the more complicated part is the thing which is inside this under root, which is b square minus 4ac, right? We call this as discriminant. We call this as discriminant. Usually we denote it by capital D. Now, if I don't want to find the actual value of the root, I just want to find the nature of the root. So I'm using a term, nature of the root. Nature of the roots. Then I can easily identify just by finding the discriminant. If this discriminant b square minus 4ac is equal to 0, for example, right? Then what will happen? This formula will reduce to the value of x, which is minus b over 2a, because everything else will become 0. So I'm getting only one root, right? So this scenario is called when the discriminant is equal to 0, I'll be getting only one root. So we say that roots are equal, right? In the previous video, I told you that actually it's a one root, but mathematically we want to say two roots, both roots are same. That's the meaning of roots are equal. Both are equal. There are two roots and both the roots are equal, right? And if b square minus 4ac is greater than 0, that means it's a positive number. It's a positive number. Then definitely I'll be getting two roots. I'll be getting two roots for sure. One with the positive sign and one with the negative sign, right? For example, in the case of this quadratic equation, we got the root 1 and 2, if you remember. Both are real roots. So we'll be getting two roots which are real. They are real number, right? And the third scenario is when b square minus 4ac is less than 0, right? I told you that we'll not be getting real roots. So here there are no real roots. But it's a contradictory. We started that quadratic equation has a degree 2. It has a maximum 2 real roots. Every time we want to ensure that the number 2 should get associated with quadratic equation. For example, here, although we are getting one root, but we are saying there are two roots, but they are equal. Why not have the similar kind of logic here? Why we are saying there are no real roots? So the important thing is that it's not like that they don't have roots. They will be having two roots, but those roots are not real. So if they are not real, then what are they? So let's take an example and analyze. I'm taking an example, x square plus x plus 1 is equal to 0. This is a quadratic equation which will have no real root. Let's see. Put it into this formula. I'll be getting comparing all a, b, and c will be equal to 1. So here it would be minus b plus minus under root of minus 1, b, the value is 1, 1 square minus 4 into 1 whole divided by 2 into 1. This is minus 1 plus minus under root of 1 minus 4, which is under root of minus 3. Oops. There is no way wherein we can write under root of minus 3 or locate the position of under root of minus 3 in number line. There is no way. That's the reason this has no real root, because this is an imaginary number. This is an imaginary number, right? Although you are getting that, sir, we can have two roots like this. Yes or no? We can have these two roots, but none of them are real because they cannot be plotted on the real number line, right? So we say that these roots are imaginary roots. So they will have two imaginary roots. So whether I say there are no real root or they have two imaginary roots, both have the same meaning. If there are no real root, then definitely they will have two imaginary roots. Or if they have two imaginary roots, that simply means that they don't have any real root. That's the meaning, right? So this is how we can identify the nature of the root just by observing the discriminant, whether it is equal to 0, greater than 0, or less than 0, right? So let's take one example. X square minus 8x plus 15 is equal to 0. We don't want the roots. We just want to figure out what will be the nature of the roots. Will the roots be equal? Are they real and different, or they are imaginary? So comparing with ax square plus bx plus c equal to 0, we get that the value of a is 1, the value of b is 8, minus 8, sorry, let me write it clearly, minus of 8, and the value of c is 15. What is discriminant? B square minus 4ac, correct? If this value is greater than 0, right, then they have two real root. Equal to 0, then equal roots. Less than 0, then imaginary root. Let's substitute the value. So it is minus 8 whole square, minus of 4 into 1 into 15. This is 64. This is 60. This is 4, which is greater than 0. That simply means that this equation has two real roots. We can identify them, right? What are the roots? Either we can use the formula or we can just split it. Here we can say that this is x square minus 3x minus of 5x plus of 15, right? You must have realized that x square into 15 is 15x square. 15 factors are 3, 5, 115 kind of thing. So 3, 5 is very much gives me a hint that their sum would be equal to 8. So I have taken that. So here it would be x minus 3. Here I'm taking 5. So here again it would be x minus 3 equal to 0. So it is x minus 5 and x minus 3 equal to 0. Each one of them, if I substitute or equate it to 0, not substitute, but equate it to 0, I will be getting the corresponding roots. So here the values of roots are 5 and 3. These are the roots, right? Real roots. The test is also done. Now, most important thing is that till now, we were using quadratic equation, or we have been given a quadratic equation and we were finding the roots, correct? What if we have to do the reverse of it? Reverse of it means I want the quadratic equation whose roots are, say, two numbers, right? For example, I want a quadratic equation whose roots are 3 and 4. Can we frame the equation right now? Till now, we used to do, we have the quadratic equation and we were getting the roots. Now we are doing something like a reverse engineering, right? We were given the root, we are given the roots and we want to frame the equation. Can we do that? Yes, we can do that. Because from here, if we are moving in this direction and getting the roots, then definitely from here we can move in the opposite direction and get the equation. Quite simple. If the roots are 3 and 5 like this, then the next step should be this. That is, each one of them can be written like this, right? Yes or no? If the quadratic equation is something here, after solving like this, we'll be getting this only. Then only we can say that after comparing each one of them to equal to 0, I'll be getting the roots at 3 and 4. Before that, what we can do is that we can just open the bracket. X into x will make it x square minus of 4x minus of 3x plus of minus 3 into minus 4 will make it 12 is equal to 0. They are like terms, so they can be added. X square minus 4 minus of 3 means minus of 7, because we can take minus in common. minus of 7x plus of 12 equal to 0. Yes, we have got that equation. That means if the equation is given, we can find the roots. If the roots are given, we can find the equation. The logic is same. Correct? So let us try this only. Can we get from this to this? It's simple. If the roots are 3 and 5, then definitely by putting the value of x is equal to 3, it should become 0. So the best idea is that take this. This should be the factor by putting the value of x, because whatever the quadratic equation is, that should be equal to 0, right? If 3 is the root, that means putting the value of x is equal to 3, that should make it 0. So I should be taking a factor x minus 3. You can just see that the moment you put the value of x here to be 3, 3 minus 3 will make it 0. The same logic we can apply for 5. So the factor should be this. Then open it. So x square minus of 5x minus of 3x plus of 15 is equal to 0. And collecting the like terms, we'll be getting this. I think that was the equation. You can see. Right? So this is how we can generate the equation if the roots are given. Okay, fine. Can we generalize this and try to identify something more about the quadratic equation? That is the objective of this session, right? So let us assume that for any quadratic equation, ax square plus bx plus c equal to 0. This is a general quadratic equation. Assuming that there are two roots, which are alpha and beta. These are the roots. So I'm using a lot of variables, right? So don't get afraid of it. I'm just making a general uh, mm, pattern. I want to just find some pattern. That's why I'm generalizing and I'm not using the number. So that once we have identified the pattern, then that will become a formula kind of thing. And every time a similar kind of thing appears, you can just apply those things in the formula. If these are the roots, and this is the quadratic equation, what I'll be doing is that I'll be doing a slight change in the format of this quadratic equation. I don't like this quadratic equation right now. I want to make some change. What is the change? I'm writing the equation as ax square plus bx plus c equal to 0. Without changing this, I am dividing both the sides by a. I'm dividing this equation, both the side by a. So I'm dividing this by a and I'm dividing this by a. Now what is 0 divided by a? 0, right? Because a into 0 is 0. Anything which divides 0 is actually equal to 0. So no impact will happen on the RHS. So RHS will remain 0. But there will be impact on LHS. The look and feel will change. A will divide by a, so I'll be getting only x square. This we can write it as b divided by a times of x, and at last we can write it this. So this is also another way of writing the same thing. Writing the same quadratic equation, correct? Right? Okay, let it be here only. Now come back. We are given the roots, two roots, and we can frame the equation. And these are the roots of this. Correct? So can I say x minus alpha would be the factor? And x minus beta would be the another factor, because by putting the value of x to be alpha, this will become 0. By putting the value of x to the beta equal to beta, this will become 0. And that should be equal to 0. Both are same. Right? Both are same. As you can see, this and this. Now let us open it. So x into x will make it x square minus beta x minus alpha x plus of alpha beta. This is equal to 0. Further, I'm writing it here. It is x square minus, I'm collecting the like terms and writing it like this. Alpha beta, sorry, this should be equal to alpha beta equal to 0. This should be equal to this should be equal to this, and this is equal to this. Simple. So what I'm doing is that I'm just ignoring the RHS. LHS would also be equal. So here we can say that x square plus b by ax plus c by a should be equal to x square minus alpha plus beta x plus of alpha beta. I have done so much of work because we have got the final fruit of it. And what is the fruit of this final comparison? On comparison, I can say that this term is equal to this term. So the term which is coefficient of x on the RHS, on the left portion of it should also be equal to this, right? Or what I can say that minus alpha plus beta should be equal to b by a. Let us multiply both the side by minus 1. It will not make any change. So here we'll be getting alpha plus beta only. Here I'll be getting minus b by a. Correct? Second, the last term should be equal to this. That is alpha into beta is equal to c by a. This is very important. If a quadratic equation has two roots, this is called sum of roots. If the quadratic equation has two roots, alpha and beta, this is called product of roots. So the two roots, sum of roots and product of roots, can be identified without actually calculating the roots. Right? For example, if I say that 3x square plus 5x minus 2 equal to 0 is a quadratic equation, you have to find, and assuming that alpha and beta are the roots, find the sum of the roots. So there are two ways. One, of course, is that apply the formula, get those two roots, the values of alpha and beta, and then add them. So it's a long way. If I use this method, then we can say that the sum of the roots is nothing but what? Minus b by a. What is b? B is the uh, coefficient of x, right? This equation is nothing but ax square plus bx plus c, right? Both are same, correct? And c is nothing but the constant term. So straight away I can say that the sum of the roots here would be what? Minus b. That means minus 5 by a. Count comparison, I'll be getting this. And the product of the roots would be this, which is minus 2 divided by 3. Straight away, just by looking at the equation, we can get it. Otherwise, we would have to find the roots, and then we have to add and multiply. So it's a very long way. So now you can appreciate that why we have done this much of thing. So always remember, for any quadratic equation in the form of ax square plus bx plus c, if the roots are alpha and beta, the sum of the roots is given by minus b by a, and the product of the root is given by c by a. Fair enough, right? This is very, very important for CAT or CAT-like exam, because most of the question from quadratic equation, we need to apply this particular either sum of the roots or product of the roots. Usually we have to apply, right? No matter what is the complexity of the question. Fine. Okay. Now what kind of question appear? So let us take a couple of questions that will make you understand that why we have come up with this relation of sum of the roots and product of the roots. And I have just noted down some of the question. Okay. Assume that there is a quadratic equation given, which is x square minus 25x plus 150. And one more thing, there are many questions, almost endless questions can be framed, which are purely based on sum of the roots and product of the roots, right? Say this is the quadratic equation, assuming that alpha and beta are the roots of this quadratic equation. They are the roots of this quadratic equation. We have to find what is the value of 1 by alpha plus 1 by beta. Again, there are two ways. Solve it, get the value of alpha and beta. Again, apply 1 by alpha plus 1 by beta. Do the maths and get the answer. You will be getting the right answer for sure, but the time taken would be more, right? Can we apply the sum of the roots or product of the roots method? Yes, we can apply. What we can do is that we can simplify it. 1 by alpha plus 1 by beta. What we can do is that I want both the denominator to be same. So I'm multiplying beta. Here it is alpha and here it is beta. I want that in denominator both should be same. So I'm multiplying this portion both on the numerator and denominator by beta. That means I'm doing this. Similarly, here it would be alpha beta. So I want to multiply both numerator and denominator by alpha. So what do I get? I'll be getting beta over alpha beta plus alpha over alpha beta. Now the denominator is same. So we can get alpha beta in the denominator, and in the numerator it would be beta plus alpha, or we can write is alpha plus beta, because it doesn't make much difference. Why we have done that? Because if these are the roots, without solving we can get the sum of the roots and we can get the product of the roots. This particular thing is converted into this format wherein the numerator is sum of the roots and the denominator is product of the roots. Can we identify the sum of the roots? Yes. Alpha plus beta would be what? Minus of b divided by a. I hope you can compare it, right? Ax square plus bx plus c equal to 0. You can compare that the value of a is 1, the value of b is minus 25, and the value of c is 150. This is equal to 25, and the product of the root is c, which is 150 divided by 1, which is 150. Just put it here. So it will be 25 divided by 150, which comes out to be 1 by 6. This is the answer. That's it. Without actually getting the roots. I hope you are getting it, that why some of the roots and product of the roots are important. Just by this example only, you would have got a big hint, right? Let's take few more examples. Do I have another example? Taken this. Okay, let's take this example. 6x square plus x minus 2 equal to 0 is an equation. Alpha and beta are the roots. We have to find the value of alpha by beta plus beta by alpha. We have to find the value of this, right? Okay, so what can we do? We have to simplify this, and we have to try to simplify in a such a way so that the terms which we get should be either sum of alpha and beta or the product, right? Because the sum of the roots of this, that is alpha plus beta, can easily be identified. Ax square plus bx plus c equal to 0. We can say that the value of a is 6, the value of b is 1, and the value of c is minus 2. If I substitute here minus b by a, it would be minus 1 by 6. And the product of the root is c by a, which is equal to minus 2 by 6, which is nothing but minus 1 by 3, right? Now let us take this alpha over beta plus beta over alpha. Again, the denominator I want to make same. So I should multiply both the side, both numerator and denominator by alpha here. And here I should multiply both, sorry, I did something wrong. Yeah, here it should be alpha. And here I should be multiplying with beta. Why I'm doing so? Because it is quite obvious that both denominator will become alpha into beta. And we want either in this term or in this term. That is another reason. So this is alpha beta, this is alpha square, and this is beta square. Some portion has been simplified. We have got alpha beta. But we don't know what is alpha square plus beta square. We know the sum of the roots. So further, we can take the help of simple algebraic identity. What is that algebraic identity? We know that a plus b whole square is nothing but a square plus b square plus 2ab. Correct? So alpha plus beta whole square is equal to alpha square plus beta square plus 2 times of alpha into beta. If you just compare, then I need this in terms of either this or this. So if I take this thing on the LHS and just rearrange them, I can say that alpha square plus beta square is nothing but alpha plus beta whole square minus 2 alpha beta. Correct? So I can write it as alpha plus beta whole square minus 2 times of alpha beta whole divided by alpha beta. Now I can just substitute the values. Let's see. So if I substitute alpha plus beta, I am getting minus 1 by 6 whole square minus of 2 times of minus of 1 by 3 whole divided by 1 by 3. Sorry, minus of 1 by 3. Okay. So let us simplify it. Here it would be 1 by 36 minus into plus 2 by 3 whole divided by minus of 1 by 3. Right? So what we can do is that we can make this as 36. So we have to multiply with how much? 12. So here it will be 12. Here also it will be 12. So this would be 1 by 36 plus 24 by 36 whole divided by minus 1 by 3. The numerator would be 25 by 36, and here it is minus 1 by 3. So we can bring 3 on the numerator. So here it is minus 1, and this 3 will go here. So which is equal to 75 divided by minus 36 or minus 75 by 36, right? So this is the value of this thing. Please check the calculation part because I have not done the actual calculation. I may make some mistakes, right? But I think this should be the answer. You should be focusing more on the process, right? If you are finding, if the process is correct and the calculation is correct, then you'll be getting the right answer. Correct? This is another way of asking the question, which is purely based on sum of the roots and product of the roots, right? Let's take one more example. This will help you the variety of question which can be formed here, right? So I'm taking one example, which is, say the quadratic equation is x square plus 2x plus 4 is equal to 0. It says that alpha and beta are the roots, and we have to find the value of 1 over alpha cube plus 1 over beta cube, right? So slightly more complicated than the previous two questions, as you can see. Doesn't matter. We can handle them. We have to just use the algebraic identities, right? What is alpha plus beta? Sum of the roots, which is minus 2 by 1, right? Now I'm not comparing ABC. You all can do. Alpha beta is nothing but 4 by 1. Fair enough? This we have to bring either in the form of alpha plus beta or alpha beta. This can be written as, we can multiply beta cube both the sides. So I'll be getting beta cube over alpha beta whole cube, plus we can multiply alpha cube on both numerator and denominator, not the side, both numerator and denominator. So it will be alpha cube over alpha beta whole cube, which can be written as alpha cube plus beta cube divided by alpha beta whole cube. Again, we know the value of alpha plus beta. We don't know the value of alpha cube plus beta cube, right? But we know the algebraic identity, which is alpha plus beta or a plus b whole cube is nothing but the expansion is a cube plus b cube plus 3 times of ab and a plus b. This is required in the form of a plus b or a into b, right? Every other terms are either a plus b or a into b. So we can apply this logic. So alpha plus beta whole cube is nothing but alpha cube plus beta cube plus 3 times of alpha beta into alpha plus beta. Take this. What will be the value of alpha cube plus beta cube? Let us write it here itself. This value can be written as this minus this. So it will be alpha plus beta whole cube minus of 3 alpha plus beta. Thoda complicated hai, but I think you can handle it. Correct? Now everything is in the form of either the sum of the roots or product of the roots. That was the objective, right? Otherwise, we have to find the value of alpha and beta separately and substitute it. That we don't want to do. Now let's substitute. So here it would be minus 2 whole cube minus of 3 into 4 into minus of 2 whole divided by 4 cube. This will become minus 8 plus of 24. This divided by 64, which is 16 divided by 64, which comes out to be 1 by 4. So this becomes our final answer, right? There are many more questions, as I said, you will be finding in the practice problems. In fact, we will be searching from the net also, you'll be finding many questions. Just search that quadratic question based on sum of the roots or product of the roots. Series of questions. Try some question on your own. Your only objective is that whatever the things given like this, you have to either use algebraic identity or some other concept, usually algebraic identity, so that it should get framed into either sum of the roots or product of the roots. Sum of the roots and product of the roots we can identify directly from the equation. We don't have to apply the formula for finding the individual roots, and just substitute the value, do those mechanical activity to get to the final answer, right?